Hello. Now you may remember that one way to find the total of the interior angles of any shape is to count the number of sides, then subtract 2 and multiply by 180. So this shape here obviously is a pentagon, so it has 5 sides. Subtract 2, we do 180 times 3, and you probably know already that that is 540 degrees. So the sum of the interior angles is 540 degrees. And the reason that works is because we can split, not very well done there, but we can split the pentagon into 3 triangles. And each triangle obviously has 180 degrees. Once we do that, we can divide by 5. 5 into 5 goes 1. 5 into 4 doesn't, so there's 0 there. 4 comes with us. 5 into 40 goes 8. So each interior angle is 108 degrees. That means because these two angles lie on a straight line, this one, which is known as the exterior angle, where we've extended one side, that is the exterior angle, can be calculated by doing 180 subtract 108. And we find that that one is 72 degrees. But there is another way of finding the size of an exterior angle of a regular pentagon, and that is actually to do 360 divided by 5. 5 into 3 won't go. 5 into 36 goes 7 times with 1 left over. 5 into 10 goes 2. So once again, we have found the value 72 degrees. So this time we have a regular hexagon. Remember, diagram not drawn accurately, that's what it'll say on most exams, because generally they won't draw them accurately so that you can't measure them. Here is a regular hexagon. Obviously it's got 6 sides, so to find the size of any of its exterior angles, there's one there, because it could be that one there. Just extend one side and find that bit there, and to do that this time it's 360 divided by 6, because there are 6 sides in a hexagon. 36 divided by 6 is obviously 6. 6 into 0 goes 0. So we know that each of these exterior angles is 60 degrees. So here's a set of regular polygons, and in each case I've extended one side so that we can see where the exterior angles are. Looking at the equilateral triangle, obviously it's got 3 sides. Divide 360 by the number of sides, so 360 divided by 3. 3 into 3 goes 1 exactly, 3 into 6 goes 2, and 3 into 0 goes 0. So the size of the exterior angle is 120 degrees. With the square, I think you've already guessed what it is, but we'll do it anyway. 4 into 3 won't go, 4 into 36 goes 9, and so the size of the exterior angle of a square is obviously 90 degrees. A regular pentagon has 5 sides. Divide 360 by 5. 5 into 3 won't go. 5 into 36 is 7 with 1 left. 5 into 10 is 2, so that's 72 degrees. A regular hexagon. 6 sides, 360 divided by 6. 6 into 3 won't go. 6 into 36 is 6. 6 into 0 is 0, so that is 60 degrees. A regular octagon, so we're dividing by 8. 8 into 3 won't go. 8 into 36 goes 4 times. 4 8s are 32, so we've got 4 left. And 8 into 40 goes 5 times. So that's 45 degrees. And a regular decagon, but dividing by 10, obviously, well, that's clearly 36. So that's 36 degrees. So that angle is 36, that one is 45, that one is 60, 72, and 90 degrees. So you can see we're developing a pretty clear rule here. The rule is to find the size of an exterior angle of a regular polygon, divide 360 by the number of sides. It's a regular polygon. So let's have a look and see what this one is. Start at the top. 1, 2, 3, 4, 5, 6, 7, 8. It's a 9-sided polygon, so it is a nonagon. 360 divided by 9. 9 into 36 goes 4 times exactly, of course, and 9 into 0 is 0. So we know that the size of the exterior angle of a regular nonagon is 40 degrees. And I'm just going to show this rule in a simpler form using a little bit of algebra. So 360 divided by n where n stands for the number of sides, will give us a, where a stands for the exterior angle. So 360 divided by n gives us a. It's worth realizing that actually 360 then divided by a would give us n. And we'll look at this again on the next part of the video. This is a typical GCSE type question where they've shown us part of a polygon. We can't tell what it's like. It would go all the way over there. We've got 3 sides. They've told us it's a regular polygon. That's very important. And they've told us the exterior angle. So let's just remember the rule we've had before. 360 divided by the number of sides gives us the exterior angle. That's the rule. 360 degrees divided by the number of sides will give us the exterior angle. But similarly, 360 degrees divided by the angle will give us the number of sides. And that makes this one really rather easy, because all we've got to do is say 360 degrees divided by 20 degrees, and we'll find the number of sides. So 360 divided by 20, there are various ways to do this division, but we'll just do it this way. 20 into 3 won't go. 20 into 36 goes 1, with 16 left over. 20 into 160, 8 times. And so we know that the number of sides is 18. And here's some questions for you to try. You could pause the video, and then when you press play again, I'll give you the answers. So here are the answers. A regular pentagon, so we know it's going to be 360 divided by 5, because a pentagon has 5 sides, and we know that 5 into 36 will go 7 times with 1 left. 5 into 10 goes 2, so the answer to that question is 72 degrees. A regular octagon is going to be 360 divided by 8. 8 into 36 goes 4 times, because 4 8s are 32, so there's 4 left. 8 into 40 goes 5 times. A regular nonagon, well, we saw that one earlier. 9 into 36 goes 4 times, 9 into 0 is 0, so that's 40 degrees. A regular dodecagon has 12 sides, so 360 divided by 12, and I expect you've already got the answer of 30. So the answer to that question, 30 degrees. Find a number of sides of each of the regular shapes with the following exterior angles. So we know that all we've got to do is 360 divided by 15. 15 into 3 won't go. 15 into 36 goes twice. 2 15s are 30, so we've got 6 left over. And 15 into 60 goes 4 times. So it's got 24 sides. 40 into 360 goes 9 times. Obviously, it's the opposite of that question there. So 9 sides. 12 degrees. So that is going to have 30 sides. 24 degrees. 24 into 36 goes 1 with 12 left over. And 24 into 120 goes 5 times. So that's got 15 sides. Thank you for watching.